So let us move on to our enlargements and center of enlargements. So I am going to share with you my wonderful program. All right. So this program is called Geogebra. Now, Geogebra is one of the most fantastic programs out there, partly because it's free, and otherwise also because you can do so much on it. You can do graphs, you can do functions, you can do shapes, you can do a whole bunch. You can do vectors, you can do calculations, you can do so much. So we need to have a look, and I'm going to show you two separate things. First thing, what happens when you enlarge a shape? So here is your original shape. All right, I'm going to take off. Just bear with me for a sec. 1, 2, 3. Okay, 1, 2. So there I have a shape. I have a very nice triangle. Oh yes, and remember as well, if you've got questions, type them in the chat as they're going. I keep it open and I'll have a look at it. So I've got a very nice triangle here. And this triangle is CBD. Great. B has coordinates 2, 2, as you can see. C has coordinates 2 and 5. And D has coordinates 5 and 2. Now, if I want to enlarge this triangle, I need to know what scale factor I'm enlarging it by. What do I mean by a scale factor? A scale factor is what am I multiplying the lengths by? So this length over here, we can clearly see is 3 units because there's 1, 2, 3 big blocks. Also, it's from 2 to 5, which means we know it's 3. This length is 3, and this length would be 3 root 2. If you aren't sure how to calculate that, you can use Pythagoras. Now, when we use an enlargement, we are going to multiply these distances of the sides by a factor, by a number. So for example, if we want to multiply it by 2, we would then get this. Now, just take note, this distance here from B to C is that line there. And we notice that it's 3 blocks to C, another 3 blocks to C dash. Again, important notation that this C dash is known as the image. The image of point C is when you enlarge or reflect or rotate or do some transformation on it. It's normally using, we normally use a little apostrophe to denote that this is the transform point of C. So that's 3, and then there's another 3 on because we're looking to double the distance from B. Now, we are keeping this center of enlargement over here. Don't worry, I'm going to talk a lot more about center of enlargement, but we are keeping it that we're enlarging it from this original point. Now, if we have a look at B, B stays, as I said. If we have a look at D, D has moved up to there. So we can see that that's 3 blocks to there, and then another 3 blocks. And if we join C dash and D dash, that line over there, this line we can see is going to be double what the original line CD was going to be. How do we know? Well, it's diagonally through 3 blocks, and this is diagonally through 6 blocks. So yes, we can find an actual length, but is it necessary? No, it's not. In decimal form, this is 4.24. In decimal form, this is 8.49 rounded off to 2 decimals, 8.48, because there's, remember I said it was root 2. so there are more decimals. All right, so this is important to remember. And if we then increase the scale factor, it's then going to get larger. So not only now do we have 3 blocks there, it's now another 3 and another 3. So whatever length this is, whatever scale factor you are multiplying it by, is the length not from C, not from the end of your triangle, but from the original point that the original side started from. So that's 1 length. Therefore, 3 lengths would start from here being 1, 2, 3. 1, 2, 3. 1, 2, 3. Have I completely lost anyone here? Type yes if I have lost you. All right, so it looks like the people that came a little bit later are a bit lost. So all we're doing is we're multiplying by a factor and we're literally counting blocks. We're counting units. Because this is 2, this is 5, therefore that is 3 units. And I'm multiplying initially by a scale factor of 2. So therefore we see that that's 1 set of 3 units, 1 set of 3 units. So in total, this length is double the original shape. And that works the same for that side, and it works the same for that side. This side would be the hypotenuse because I've constructed this to be a right angle triangle. And no matter what scale factor we use, the triangle just gets bigger and bigger. All right. So that enlargement doesn't look too bad. I mean, we can deal with that. We can go all the way down to 1, D, D, D. Okay, great. What happens, though, when we move our center of enlargement? This is where our life becomes more difficult. So just normal center of enlargement, that is your book 1 stuff. Dealing with your center of enlargement comes to your book 2 stuff. So what happens if we now move our center of enlargement? Well, if we move it back, and I'm going to just show a couple points again. So this over here is my center of enlargement. So that's the black writing over there. All right, I'm now going to move my center of enlargement away. Now look what's happened to my triangle. My triangle is now no longer on my brown triangle. It seems to be shifted off of it. Why? Well, we need to use the definition that I gave you. The definition was that it's the distance from my center of enlargement, which initially sat on B, and I said it was the side length, because it is, from the center of enlargement to a vertex. That needs to be consistent. So if your factor is doubled, it needs to be the distance from center of enlargement to a vertex doubled. Now that we move it, we see that the distance from the center of enlargement to B needs to be doubled to get to B dash. So that is the diagonal of 1 block. Therefore, B dash would be the diagonal of 2 blocks. So I can show you that by there we see that this distance is 1.41. That is the square root of 2. And doubled, this 2.83 is the whole length. The length is doubled. Hopefully I'm getting this through. If we have a look at this distance here, from our center of enlargement up to C, that length is 4.12. But again, it's this distance from the center of enlargement to the vertex. And in a straight line, we then need to continue double that length, and we get to C dash, 8.25, and it's 5 because it's rounded off. It's double that distance. Similarly here, that distance there is your 4.12 because it's going to be the same. And then if you increase that line, you need a whole nother one of these lines from there to make the length doubled. So if I move it again, we now notice that this triangle is now shifted further out because this distance from my center of enlargement to the vertices is larger, which means that these vertices have to be further out because the whole length is going to have to be double a larger value. So this length is now 5.39. Therefore, double that distance, 10.77, pushes it further out. Now, maybe these lengths are confusing you. Remember, you can also use it as how many up and how many across, just like you calculate a gradient. So we're going 5 up, 2 across. Then we go again, 5 up, 2 across. Here we're going 2 up, 2 across, 2 up, 2 across. So the further we move it, the further away that triangle is going to be. So if we go from here to B, it is 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 to the right. To get now to B dash, you need to do another 5 and 5. 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 across. And it works the exact same way from there to D and D dash, or C and C dash. But note the size of this triangle. The size of the triangle is still only a scale factor of 2. So it is not changing in size, where you see it's still double. So the length there is 3, the length there is 6. That length is still 3, that length is still 6. And that is crucial. All you're doing is by changing the center of enlargement, you are changing where you're going to be putting the triangle. Any questions on this at the moment? All right, so please, again, it is absolutely crucial you keep in mind both things, that you have just enlargement and then where your center of enlargement is. So I'm going to just one more time show you. So you can have where it starts going backwards through, but that's for a whole nother lesson. All right, so I'm going to increase my scale factor here a little bit more. I'm going to zoom out a little bit. And now if I move this, we see the triangle is now moving far more, and far more by value, because it has to be bigger to start with. And we can see it just keeps shifting longer and longer and longer. It's all the way over there. And if I make it larger, it's going to push even further. So we need to make sure that we keep this idea no matter what. And amazingly, all of this comes from just one base triangle. So if we change this triangle, everything will change. And if you change your center of enlargement, everything is going to change. And if you change your enlargement scale factor, everything's going to change.